ኤዩ ፊዚካ ነው። ስለዚህም ቀደም ብለን ካየናቸው የሃርሞኒክ ሞሽን ፕሮብለሞች አያይዘን ሌላ ቤዚክ የሆኑ ኤሌመንታሪ የሆኑ ሃርሞኒክ ሞሽን ኮንሰፕቶችን እናያለን። ይሄ ፕሮብለም ሜይንሊ ተዘጋጀው as a general revision ነው። ጥያቄው ሁሉንም ፖይንቶች ተች ያደርጋል። ኦልሞስት እዚህ ጋር ጥያቄው ላይ እንደምትመለከቱት አክቹዋሊ ጥያቄውን በማንበብ ጀምራለሁ። ሁሎችንም ሃርሞኒክ ሞሽን ላይ ያየናቸውን ኮንሰፕቶችን የምንፈልግ ይሆናል። በጥያቄው መሰረት ቀጥታ አበባን ኢንተርፕሬት አድርገን እንሰራለን ማለት ነው አብረን። ተስፋ አድርጋለሁ አብራችሁኝ ለጎን እየሰራችሁ እንደሆነ ማለት ነው። መልካም። ስለዚህ to begin with the question, here the question says a spring of negligible mass stretched 3.00 centimeter from its relaxed length when a force of 7.5 Newton is applied. A 0.5 kilogram particle rests on a frictionless horizontal surface and is attached to the free end of the spring. The particle is displaced from the origin to 0.25 centimeter and released from rest at t equals to 0. So that's so good. So according to the first initial thing, let's simply illustrate the given information here. So here we have given a mass spring system. So a certain particle is attached to a wall of spring constant K. And the question from the given information, so as the particle pushed by 7.5 Newton, so the spring is stretched by what? 3.00 centimeter. So here, the particle begin to displace by applying a force of 7.5 Newton. It displaces displacement of x equals 3 centimeter. That's so nice. This is of course to find the Hooke's constant. In fact, here the attached ion mass, it weighs about 0.5 kg, and also we have given that the oscillation is occurred in a situation where the mass is displaced to a point where x equals to 5 centimeter. So motion የሚጀምረው harmonic motion የሚጀምረው from what? X max of maximum displacement of at 5 centimeter now. So let's say this is a maximum displacement in which the ball released from. So good. So from this given information, in fact, this is a point at which time is equals to 0. So which is the initially displaced hono 5 centimeter. Initially ወይም at motion ከመጀመሩ በፊት ያለበት position ነው x max here. So nice. So from the given information, we are asked here in part A, we are asked to find a constant of spring. So A የሚጠይቀን find the Hooke's constant ነው, find K ነው. So Hooke's constant according to, or simply the spring constant, can be found from Hooke's law. So according to Hooke's law, the force applied to a spring is proportional to the displacement, or simply multiplied by a Hooke's constant times the displacement of a particle. So in fact, from our given information, 7.5 ኒውተን አፕላይ አድርገን 3 ሴንቲሜትር ዲስፕሌስ ካደረገ, now it's easy to find the Hooke's constant. Hence K would be the force applied on the particle divided by the displacement of the particle. So remember that here x 3 centimeter እና 5 centimeter differentiate ማድረግ አለብን። ይህ 3 centimeter ፓርቲክሉ በ7.5 ኒውተን ዲስፕሌስ የሆነበት ዲስፕሌስመንት ነው። ኢትስ ኖት ዘ አምፕሊቲዩድ ፕሪቪየስሊ ከዚህ በኋላ እንመለከታለን አክቹዋሊ። ሶ it will be with simple substitution. The force is given here 7.5 Newton divided by 3 centimeter, or simply 0.03 meter. So one can find a Hooke's constant or a spring constant of 250 Newton per meter. So that's a key ingredient for harmonic motion, because Hooke's or the spring constant ከዚህ በኋላ ለምሰራቸው ለሚጠየቁ ጥያቄዎች ኢንግሪዲየንት ነው፣ ቤዚክስ የሆነ ነገር ስለሆነ ነው። So here we have found the Hooke's constant. So of course in part B we are asked to find the angular frequency, the frequency and period of motion. So we need to be careful here. We are asked first to find the angular frequency omega, and next we will find the frequency of the oscillation, and also finally we will find the period of oscillation. So these are simply that we are going to find. So in the first thing from previous discussion, we said that the angular frequency is simply under radical of the spring constant divided by the mass. So here the angular frequency would be simply by putting this all information. We have given that the mass of watts here 0.5 kilogram, and also have calculated Hooke's constant 250 Newton per meter divided by 0.5 kilogram, and one can find with simple calculation here that approximately you would find 3 points, with simply use a scientific calculator, and you will find 22.36 rad per second. That's nice. Here we have found the angular frequency, and next would be we need to find the frequency. So frequency would be found from the relation that, since we said that the angular frequency is simply 2 pi radian times the frequency. So in other ways to say that the frequency is simply omega divided by the 2 pi. So here with simple calculation 22.36 rad per second divided by 2 pi radian. Remember ማድረግ ያለባችሁ here angular frequency ስንሰራ here the unit specified that the radian measurement should be put after calculation. Mostly you don't get an rad form, but this expression gives us a rad per second. So mostly ባይሰጠንም ራድ የሚል ኤክስፕሬሽን ባናገኝም የለም ማለት አይደለም, because here the angular frequency is measured in unit of rad per second, so we should specify with this unit. So finally here 2 pi simply is the radian measurement by cancelling the radian unit, so you will find a result of 3.56 second inverse, or frequency is measured in terms of hertz, so we should specify by its unit 56 hertz. This would be the frequency, and if you found the frequency it's easy to find the period. So from the relation, period is 1 over f, the frequency, this would be 1 over 56 second inverse, so we'll get approximately 0.28 of second. That's so fine, that's so good. And of course ወደ ላይ ሄደን ጥያቄያችን ስንመለከት ሲ ላይ what is the amplitude of the motion? So አምፕሊቲዩዱን የኦሲሌሽናችን የኦሲሌሽኑ አምፕሊቲዩዱ from given information we have seen that ወደ ዲያግራማችን ስንሄድ ፓርቲክላችን ዲስፕሌስድ የሆነው ማክሲመም to a point where it reaches 5 centimeter now at equals to 0. ሶ ከዚህ ነው ሪሊዝ ማድረግ የምንጀምረው። ሞሽኑ የሚጀምረው ወይም ኦሲሌት ማድረግ የሚጀምረው ፍሮም 5 ሴንቲሜትር ነው። ሶ ዲስ ውድ ቢ the amplitude or the maximum displacement that a ball or a particle could travel. So simply an amplitude is given by 5 centimeter. So in part C, the amplitude, or simply A, is equals to a maximum displacement. That being said, the amplitude would be the x max, or amplitude would be in this case 5 centimeter. So good. So if you found now basics የሆኑ ነገሮችን ካልኩሌት አድርገናል, and in part D we are asked to find what is the total energy of the system. So that would be easy to find. Then here in part C, in part D we are looking for the total energy. So actually the total energy, oscillation action total energy is the sum of potential and kinetic energy. The kinetic energy plus potential energy. But because of a lack of information here, we don't know at specific point ላይ ያንዳንዱ kinetic energy እና potential energy ማወቅ ያስፈልገናል። So from conservation of energy, total energy is simply equals to the maximum potential energy. Maximum potential የሚኖረን መቼ ነው? ፓርቲክላችን to maximum displacement ላይ ከኢኩሊብሪየም ፖይንቱ ዲስፕሌስድ በሚሆንበት ጊዜ ነው። So at that maximum displacement, x max, you would get, at this point, you would get a maximum potential energy. So, of course, at that point, the kinetic energy is, of course, zero. So that being said, here the total energy would be the maximum strain energy or potential energy. So, simple calculation, the maximum or the potential energy maximum is simply half times the spring constant k times the amplitude square would be the maximum potential energy. So with simple substitution, this would be half of, with the spring constant of from the previous results, 250 Newton per meter times the amplitude is of course 0.05 meter or 5 centimeter of squared here. In fact, finally we would get a result of approximately 6.25 of joule. So this will be, of course, the maximum potential energy. So therefore, the total energy is simply the maximum potential energy, or 6.25 of joule. That's so nice. So here basics የሆኑ ነገሮችን አይተናል. And finally in part E ላይ we are asked to find what are the maximum velocity and the maximum acceleration of the particle. So this would be easy to calculate the maximum velocity and the maximum acceleration from the previous. Let me go once again. So for simple harmonic motion, actually have you can show that here ብዙም ዲቴይል የሆነ ፕሩፍ ያስፈልገናል። in parts actually let me go here we have in part E. So V max, So the maximum velocity of the oscillation, we have to see that the angular frequency times the amplitude. So that being said, this will be equals to, here from our result, the omega is simply 22.36 rad per second times the amplitude is given by 0.05 meter, and you will get approximately 1.12 meter per second. So this will be the maximum velocity. In fact, from a given thing, one can calculate simply the maximum Vmax, the maximum acceleration, also given by Amax, is also given by omega squared times the amplitude. So here the omega is given, so omega is 22.36 alpha squared times the amplitude here of 0.05. Sorry, here ዩኒቱን ማስቀመጥ እንችላለን lastly. So of course you don't need here any detail here, you can just go ahead and use your scientific calculator. So this would be 22.36 squared times 0.05. Of course finally you'd get approximately 24 or approximately 25 meter per second squared. 25.00 meter per second of squared. This would give you the maximum acceleration. So here now basic የሆኑ ነገሮችን አይተናል. Of course on the final parts we are asked also to determine the displacement x of the particle from the equilibrium position at x equals to 0.5 second. ተመሳሳዩን በቀጣዩንም ጂም ላይ የሚጠይቀን velocity acceleration of the particle when t equals to 0.5 seconds. So ሁለቱንም ጥያቄዎች በአንድ ላይ መስራት እንችላለን ማለት ነው። so ምንድነው previously ያየነው so basics የሆኑ maximum velocity, maximum acceleration አይተናል, and also the amplitude አይተናል, which is the maximum displacement. But here we are asked at specific time instantaneously what will be the acceleration, velocity and displacement. So that being said, on F we are asked to find x at 0.5 second. And also we are asked in parts in G, of course, the velocity at 0.5 second and the acceleration at 0.5 second. So ይሄን ለመስራት ምንድን ማየት አለብን? oscillation motionaችን it should be expressed in terms of a time, as a function of time. So the position here oscillation ሲጀምር ከማክሲመም displacement now from A of 0.05 meter ነው displace ማድረግ ከኢኩሊብሪየም ፖይንቱ at t equals to 0 ጋር ማለት ነው። so displacementአችን at time equals to 0 ላይ maximum ከሆነ it should be expressed in terms of a cosine function. So the position of the particle as a function of t should be expressed a times the amplitude times the cosine of omega times t. In fact here phase አንግላችን ወይም phase angle degree 0 ነው ማለት ነው። ወይም ከ0 ነው የተነሳ ማለት here plus 0 degree ነው ማለት ነው at t equals to 0 ላይ ማለት ነው, because displacement is maximum at t equals to 0 ላይ. Hence now with simple calculation the position at 0.5 will be simply the amplitude 0.05 centimeter times cosine of 22.36 times 0.5 second and simply one can find the result of 4.91 centimeter approximately. You get 4.91, and then we need to find the velocity at 0.5 and acceleration. So to do that, the velocity should be expressed cosine, or simply a time varying function. It should be a time varying function. So we have seen that the velocity at any time of t would be the derivatives of the position as a function of t. So that gives us, of course, here a minus of a omega derivating here. እዚህ ጋር ነው ደሪቬት የምናደርገው ፖዚሽናችን ተስላለን as a function of cosine omega minus of omega sine of omega t. In fact, this is minus 0.05 meter times angular frequency is 22.36 meter times sine of 22.36 times the time is 0.5 second. Sorry, and you would get approximately negative 0.22 meters per second squared. So here is the velocity at 0.5 second. Okay, so this is the next thing will be to calculate the acceleration. So at 0.5, this is in fact velocity at 0.5. Alright, so acceleration at any time of t is also expressed as a function of t, or simply second derivative of the position, or simply the first derivative of the velocity, or simply the second derivation of t. So this would be simply derivating once more the velocity. You would get minus a omega squared cosine of omega t. So arithmetic calculation now. So minus 0.05 meter times 22.36 rad per second squared cosine of 22.36 times 0.5 second. So with the result you would find negative 24.52 meter per second squared. This gives us the acceleration. So በጠቅላላ ጀነራላይዝ አድርገው እዚህ ጋር ያየናቸው ፖይንቶች ቤዚክ ሃርሞኒክ ሞሽን ላይ እንደ ፕሪሊሚናሪ የሆኑ ኮንሰፕቶች ናቸው። ሶ ከተሰጡን ጊቨን ኢንፎርሜሽናችን ኢንዳይሬክትሊ የተጠየቁትን ጥያቄዎች መመለስ እንችላለን ማለት ነው። ሶ ከዚህ ቪዲዮ ቤዚክ የሆነ አይዲያ እንዳገኛችሁ ተስፋ አደርጋለሁ። በለጠም ደግሞ ፕሪቪየስሊ ከሰራ ነው ፕሮብለሞች ተመልክታችሁ ከዚህ በኋላ በሚመጡት ፕሮብለም ጋር የበለጠ ስኪል እንደምታዳብሩ ተስፋ አደርጋለሁ። So I'll see you on the next video. Bye bye.